Hello, everyone, and welcome to the 53rd episode of Tech Life Skills with Tanmay. My name is Tanmay Ep.53. Thank you very much for joining me today. And here's a question. How can you successfully deploy AI? Now, that's one of those questions where it looks simple enough on the surface, like conceptually, right? But then once you start digging into it, you realize that you've opened one of the largest cans of worms to exist. And all that goes all the way from getting labeled data to ensuring the validity and the quality of that data, analyzing societal biases within it, mitigating negative outcomes of the application of the AI. The list just goes on and on. But that is actually the question that we're going to work towards answering today with our very special guest, Alyssa Rochwerger. Now, Alyssa is the Director of Product Management for Blue Shield of California, and she's also held lots of other roles, like, for example, Director of Product Management for IBM Watson, and Director of Data and AI for Appen. However, I will say that my favorite title of hers is that she's a self-proclaimed data nerd, and so I can absolutely relate to that. And so now, without any further ado, I'd absolutely love to go ahead and welcome Alyssa to the show. Hi, Alyssa, how are you?
Thanks so much for having me. Good to be here.
Thank you very much. It's great to have you on the show. I'm really excited to hear your thoughts around the world of AI. But before we dig into that, I'd love to hear a little bit more about what you do. Would you maybe like to, quickly introduce yourself and tell us all about how you got here?
How did I get here? Well, I have a liberal arts degree in American Studies and photography, so certainly not through my education, but I do rely on that a lot in my job. I've had a bit of a circuitous route through technology, but I took a leap of faith about 7 years ago or so. I can't remember exactly. And ended up with a job in the IBM Watson division and had the privilege of learning from some other really wonderful folks who I believe some of whom you've had on your show, all about sort of what machine learning technology is and how to use it. And I was privileged enough to get to work behind the scenes on a lot of cool projects. So that's how I got my first taste of AI. I found it to be a really powerful, fascinating, interesting technology. And currently, I'm actually sort of took a hard left turn and pivoted to the healthcare space. And I've been privileged enough to spend the last 9 weeks dropping my day job on the floor and working on the vaccine rollout for the state of California.
Very nice. It's great to hear. It's nice to hear first of all that you've transitioned into a field where technology really has such a big impact on people's lives. But it's also really nice to hear that your sort of journey into the world of machine learning started with Watson, which is actually another tie-in to my journey into the world of machine learning. Right, like the way that I got into the world of AI and really all sorts of next generation technologies was simply through watching Watson play Jeopardy, which then led me to the APIs that IBM offers and so much more. So, I'm very glad to hear that as well. Now, one thing that I do want to start off by asking, I just want to dive straight into this. I feel like artificial intelligence and science fiction really go hand in hand, right? And the reason for that is because for the longest time now, we have been absolutely sort of obsessed with trying to make computers intelligent. And if we weren't able to do that in real life up until, recently with certain tasks like maybe GPT-2 or other kinds of neural networks that look intelligent, and we'll get into that in a minute, then we've at least tried to, represent computers as intelligent in a lot of science fiction. And so whenever you talk about artificial intelligence, a lot of people immediately in their mind start to picture, science fiction characters, maybe like, TV shows or movies like Westworld or something of that sort. And my question for you is, based off of your experience and the work that you've done, how does real world artificial intelligence differ from what people see in science fiction? What is that difference?
So in my experience, real world machine learning based products are fairly dumb. And I say that because what they often come down to are very, very narrow decisions that you are asking a machine learning or computer system to make that is fairly simple. And you're asking it to classify new information into a category, generally speaking. There's lots of other types of machine learning, but a lot of the real world stuff that I see is You're just trying to do a classification task. Sometimes it's very complex and sometimes it's very simple. So I'll take a voice assistant as an example. As we're talking, a voice assistant is listening to unstructured audio and is trying to classify it into a set of known words. In the English language, there's only so many non-proper nouns that it could be that word. And what it's trying to do is take your audio and transition it and classify it into something it already knows. And that's kind of what a lot of machine learning technology is in the real world, is a very sort of fancy, simple decision for very, very, very narrow discrete tasks. But when you add them up all together, it can often be really cool and interesting if you're layering on many, many, many decisions on top of each other to perform what otherwise may seem like a human level type of decision.
Interesting. So, maybe the greatest example that you just sort of gave here, something that everybody can relate to, is voice assistants. Because, like, if you think about something like the Google Home, for example, right? When you give it an utterance, right? When you're like, okay, Google, I want to do this. Okay, Google, what's the weather going to be like tomorrow? Right? There's so much machine learning that goes behind that makes it look like such a human thing, right? All the way from recognizing the wake word, right? That's a very specialized form of speech to text. Then being able to take the rest of your utterance and convert that to actual text that the next machine learning process, the sort of natural language processing engine, can then actually go ahead and analyze and understand. Then from there, taking the structured response from that system, trying to understand what exactly the user is asking for, go to another API, find the weather, which itself might be powered by machine learning to predict the weather, right? So if you're using IBM, the weather company, you're using machine learning there, and then coming back and taking that structured response and then providing that as unstructured data, right? Text to speech, audio.
Yeah.
That's an entire
What
sort of
I
machine learning
found
pipeline.
is often these fancy looking systems that perform complex tasks are really just a series of very small, narrow ones.
Absolutely, right? And so that sort of is where it starts to differ from real world intelligence, as well as what we see in the world of science fiction, at least in a lot of them, where we see these sorts of generally intelligent, unstructured systems. As a matter of fact, actually, before we dig deeper into this, there is one more thing that I want to talk about. And I know that you recently co-authored a new book called Realworld AI. And before we continue, before we dive deeper into the world of AI and data and how businesses should be reacting to this, would you maybe like to tell everybody a little bit more about that book and sort of what your thoughts were when you started writing that book and what you've tried to get across?
Sure. Yeah, I even have a copy here. I'll be pleased to send you one. Just need your address. But this book is really, it's a collection of stories, and it's a behind the scenes look with myself and my co-author Wilson Pang on our experience and many others who we've encountered along our way into what happens behind the scenes and how to responsibly deploy machine learning based products into production. What we've both had the opportunity to learn, sometimes the hard way, and we'll share those stories in the book as well, is that deploying a machine learning product at scale to reach consumers, millions of them, is a really different type of effort than it is to release a small pilot project or sort of a narrow tinkering type of toy or application. But when you're doing it in a public company, when you're trying to make money off of it, or you're trying to put it into a business critical decision where there is risk involved and lots of lawyers and high speed systems, that's a pretty different level of effort. And what we try to break down in the book is sort of a practical guide on how to do that and how to go from, oh wow, I want machine learning, or oh, I think I need it, to what are the intelligent decisions, what are the questions that you can ask as a business person that don't require a machine learning degree or a computer science background to participate in the process and be able to use and harness this technology for whatever purpose it's a good fit for.
Wonderful. Thank you for sharing. I absolutely love your mission because it ties in a lot to what I like to do, right? Because I feel like I've met so many people within the world of technology that just have so many interesting experiences, which is why I have this sort of platform of Tech Life Skills to help people share that and help people sort of tap into that insight. And I feel like you're doing the same thing, right? So the same basic concept. And I mean, I myself am really personally excited to hear about what these people's thoughts are into the world of machine learning and their industry experience. And so I would definitely love a copy. And as a matter of fact, I will be putting the title and a link where everybody can go ahead and get a copy of this book for themselves down in the description below as well. So make sure you check that out. Right, so now one thing I do want to get a little bit deeper into, starting off with a question from the audience. And this one's from Shiva. So Shiva's asking, and this one's a little bit more open-ended, but if you still have any thoughts around this in particular, I'd love to hear it. What are the core capabilities of an AI system for business? What are your thoughts on that?
Sure. Great question. Thank you for it. I think, it really starts with the core component is understanding the problem that you are trying to solve for. I think that's really the mistake that often people skip. And then downstream, there's lots of technical systems, and I can go into that, but I'll start with actually, you need to define the problem that you are solving for in business, and you need to make sure that that business problem has value, like dollars attached to it, typically in business. Sometimes it's time or sometimes it's efficiency, but usually, if you can't break that problem down into dollars, it's not that valuable for the company. So take even something like a big Facebook, right, or any social media platform. At the end of the day, there are advertising dollars associated with improving search relevance or improving the image tagging system or whatever it is, because that's how they make money. And often what I see folks who are trying to deploy AI in business is they skip over that problem definition part and they go right into the data acquisition and perhaps even model building stage, and they come up with an algorithm or and sometimes even a prototype, and then you're like, wait, how, like, so what, right? Like, who cares? And so I always encourage people to spend like 80% of your time on the problem space, really understand that problem, understand who is benefiting from it, understand who might not benefit from it, because that's often just as critical, because you want to really understand when you're introducing a machine learning system, you're asking it to make a decision. And if that decision is one that otherwise a human would normally make with empathy and constraints and reason and all sorts of things, and you're offloading that decision, there could be times when you could introduce a harmful bias unintentionally. And so that's also something we spend a lot of time in the book, is how to build machine learning systems and set them up for success from a responsibility perspective.
Right. So, I mean, I feel like this ties kind of into a discussion that I had actually in the very last episode with, I guess, last episode's host, since it was an Ask Tanmay episode, Michael, and he was talking about how, within the world of technology, everything eventually boils down to money, right? It boils down to a company, if they're implementing this machine learning system, what's in it for them? How much, X percentage can they increase their revenue or their profit based off of whatever it is that they're implementing? And what's interesting is that a lot of the research that's happening today actually does, at the end of the day, have that company's interest in mind. So that could be, for example, Google, how they've effectively reinvented the world of natural language processing with BERT. If you think about it, they did it specifically to increase search relevance, which could then also help them advertise more, because then you're using Google more because it has more relevant search results. And there's so much that they can do with that, right? All the way from understanding you better as a person to be able to give you better ads to, so much more. And so all of these advances fundamentally have that sort of business in the background. But going back to actually one of the episodes that we did with I'm unfortunately forgetting his name, but it was an episode with an IBMer, Animesh was his name, and he was talking about how machine learning has traditionally been this sort of field with a lot of scientists, and it's been mostly a science-driven field. And so now we need to bring sort of that engineering rigor and sort of discipline into machine learning to be able to deploy it. But it also needs a lot more sort of business discipline, I think, right? Because with technology this powerful that sort of fundamentally shifts what you can do with technology, it becomes really important to understand what you can and can't do with it in order to apply it well, and also what the risks are and things like this. And actually digging a little bit deeper into those sorts of risks and sort of what people should be thinking about, another sort of question that I wanted to ask was, when businesses are sort of thinking about implementing AI, what should that why be, right? So why exactly should businesses be implementing artificial intelligence in the first place? Like, what are some of the things it can do for them? But then also at the same time, what can machine learning do for business leaders in the first place?
Yeah, absolutely. I'm flipping through my book here to see if I can get to the right page, but I can't find it easily. But I'll reference actually Google Chief Decision Scientist Cassie. I'm not going to get the quote right, so I won't try to quote her off the book. But basically, what she recommends is if you don't have to use AI or machine learning, don't. Right? Like if you only want to use machine learning or AI, if you have tried every other sort of normal way to solve a problem, because it's really hard and it's really expensive. And not all problems are well suited for machine learning. So I always like to start with that, which is, if you should approach machine learning technology with a humility that it's hard, it's going to take a while. Typically speaking, it doesn't always have to. It can be, pretty fast, but businesses should be using it to solve problems that they can't otherwise tackle with other technologies. And so it's typically problems that are well suited for AI, or ones that have a really sort of narrow decision-making criteria, right? It's yes or no. You're trying to classify something into a few categories, and you have a lot of data, right? You have tons and tons of hopefully structured or strong data that you can bring to the table, and that you have been able to solve previously, and that solving this problem has an outsized positive impact for a very clear business metric. So I'll take support ticket classification. So if you are like a ride sharing company like Lyft or Uber, and you are trying to classify support tickets, and you're trying to say, oh, this is a technical problem, or oh, this person is writing in because they had a bad experience with a driver, or whatever else. If correctly classifying those into severity of like how fast we have to get back to this person. So you might classify the same ticket on a number of different sort of scales, essentially, like, oh, this is the category it's about, and this is how severe, this is how urgent. If you misclassify something, say someone writing in about alleged sexual assault, and you misclassify it as not urgent, accidentally, the harm to your business of getting that wrong could be potentially really high. On the flip side, the value in getting it right, if you correctly classify it and understand that someone's writing in about sexual assault, and instantly route it to 911 or the authorities or whatever the appropriate way to route it is, that could actually be really positive to your business. And so often these types of machine learning problems go both ways. They can be really great, or they could also be really problematic, and you're often introducing risk. And so you just sort of have to think about what is the outsized positive impact that is, and how that is worth some of the risk mitigating.
Right. I mean, I feel like that ties into a couple different things, where first of all, humans are really good at two things. A, being, at least in a lot of cases, predictable, but also being unpredictable enough to create some really weird edge cases. Like, there are ways that humans will find to break software that not even the most talented engineers could think of, right? Like, I mean, there's this one YouTube channel, I'm forgetting its, I think it's called Let's Game It Out or something of that sort, and literally his whole sort of shtick is taking games and effectively breaking them, right? Finding the absolute limits of where they can go from an engineering perspective. And every single time, like clockwork, he's able to find lots of different bugs to exploit to win the games in as weird of a manner as possible, right? And so humans are really good at coming up with edge cases, but at the same time, humans are oddly predictable, right?
Mhm.
It's weird just how much we think we are unique, but we're actually not. Like this reminds me of a Stanford, I believe it was a probability class, where the professor said that if everybody can write, or if somebody can provide me with like a sequence of, I believe it was ones and zeros, that is indistinguishable from, or sorry, two separate random sequences where he cannot classify who wrote the two separate random sequences, right? Not using an actual random number generator or something, just coming up with them off the top of his head, then they'd pass the class, full grade, not having to do anything else. And nobody was able to do it because humans are just that predictable in terms of probability, right? Like I remember this one time I was scraping tons of music from the Genius website, and even though this is relatively standard distributions, still it always surprised me as to how, as I was randomly scraping data, the ratio of the genres of all the music would stay basically the same, right? It's completely random scraping, and yet the sort of
Yeah.
ratios are staying the same, right? And so humans are relatively predictable. And so what that means is with machine learning, you can apply things like expected value to try and figure out, overall, if we have across 100,000 support tickets, if we have this level of accuracy, what kind of
Mhm.
value can we expect to get if this accuracy continues to be constant at that rate? But
Mhm.
then we also have to think about the fact that data evolves over time, right? The way that people are going to be sending in support tickets
Yeah.
is going to evolve. It's going to change. You've got to keep retraining. There's so many things to take into account, which is why I love your mention of only use machine learning if you absolutely have to. There have been too many times where I will be in a meeting with somebody who isn't necessarily very technical, and they'll be like, we want to use machine learning or we want to use AI to do this thing, and I'm like, we don't need to. And a couple months later, we'll be implementing an entire system based off of nothing but a couple of simple heuristics that works way better than machine learning ever
Yeah.
would have, right? It reminds me just one last thing of that really famous little funny flow chart where the guy at the conference was going, "Do you need blockchain? No." So, again with machine learning, by default, it's a no until you really need it. So I think that's important to keep in mind. And so this does open up the entire other debate of, what is good data in the first place? And I want to ask you about that in a second. But first, I want to take up a question from the audience really quickly. This is from Akshay Kapoor asking, what is the difference between AI and ML, machine learning? So what are your thoughts on that?
Sure. I spend some time on this in my book, but and there's a lot of different definitions of AI. Some people say artificial intelligence, some people say augmented intelligence. I think of AI as a big circle of things, and I think of machine learning as a more specific set of technologies that are referenced within the broader world of AI as artificial intelligence or augmented intelligence. And machine learning is sort of a more narrow, more technical term that applies to a collection of technologies. Even more narrow is sort of deep learning within the field of machine learning. Deep learning or neural networks is sort of a lot of what more modern machine learning based approaches are today.
Right. So a lot of modern machine learning is deep learning, which is sort of where that magical sort of next generation technology view comes in for a lot of people. A lot of the things that we can do with tech today that we call AI that we couldn't in the past is thanks to deep
Yeah.
learning.
The other thing I like to talk about this sort of, as concentric circles perhaps,
Mm-hmm.
is if you're only doing deep learning or you're only doing machine learning, you sometimes are not doing artificial intelligence.
Interesting.
Because in order to make something feel like it actually is artificial intelligence, you need a lot more than just machine learning in order to kind of create that feel of magic or cool, right? You need design, you need a user experience that's really cogent. You need to actually deploy it into production and have it like work really fast. You need all these other sort of collection of skills and a team in order to make a product actually feel artificially intelligent.
I absolutely love that because, you sort of made me think about this a whole new way, where artificial intelligence is less of an implementation detail and more of a user experience thing, right?
Yeah.
Because machine learning, one of the things that I've always sort of talked about and something that has almost not necessarily confused, but for lack of a better word, I guess confused me, is when we look at something like Pepper the Robot, like we're like, artificial intelligence. But when you take the exact same sort of math and deep learning tech that goes behind something else, like for example, fall detection on the Apple Watch, suddenly we go from calling that artificial intelligence to maybe machine learning if you're a technologist, or just another Apple Watch feature if you're a regular consumer. And the reason for that, actually, you've brought this to my attention, is user experience. With Pepper the robot, you've got that humanoid sort of experience. It feels intelligent. It feels like it was made to be intelligent. When the Apple Watch detects a fall, it's just doing what it was meant to do. It's sensing, using the accelerometer and gyroscope that you took a fall. That's it. So, what I
But
absolutely
yeah, I think that's often missed, is the disconnect between it works on my laptop and the math works and it's cool and it correctly did and took an input and created an output, to someone was able to use this for a purpose that was valuable to them, right? Like the fall detector, on your watch, for example. Who gives who cares if it's just on your laptop, right? It only works if it's actually on your watch and you fell and it could call 911 and you're 90 years old, right? And so all of this has to kind of work in harmony.
Absolutely. So then there's that sort of, of course there's a lot more to it, but there's the multiple different sort of stages we've seen from, it just works on someone's laptop, you can graph out the accelerometer and gyroscope data and detect that someone took a fall, to then being able to deploy and say, you know what, now we can automatically call 911, get you the help you need, save lives, so people can actually use it. And then there's the next step up from there, which is this machine learning technology is put into a package that seems artificially intelligent. Whether that is a vacuuming robot like a Roomba that they allow you to name and sort of interact with on an app, or if that's Siri on your phone, whatever it might be, when you actually sort of give it that interface that feels intelligent, that's when you upgrade it to AI in a lot of people's eyes.
Right. Or the other way, right? Which is if it works right on your watch and it's cool and you can interact with the machine learning works, but your grandmother would never buy it, right? Or you give it to her as a gift, but it sits on her bedside table because she doesn't like wearing it, right? Those are also problems that you have to solve in order to get the value out of that technology.
Right, absolutely. Reminds me of the Apple Watch I gave to my sister, but apparently she doesn't really like smartwatches all that much, so she's wearing the other watch. But it's really just as a technologist, whenever I do something, there's always that thing in the back of my mind going, how does that work? How the fact that it uses that technology is what's so interesting to me, and so that's particularly why I like things like the Apple Watch, not because it's an Apple Watch, but because think about the technology that goes behind that, right? Think about how exactly that works. The fact that you can put more compute power than the CPUs that are even on like the Perseverance rover today on your wrist is incredible, right? And so, to think that that's possible is something that really it drives me to do a lot of things, but that's because I'm a technologist. That adds value to me, right? That curiosity. But a lot of people don't really care about that technology, right? Going back to the example of my sister, she doesn't care that an Apple Watch has this weird, S1 system on a chip, whatever, right? She just cares about what can it do for her, right? And same thing with a lot of other people. They care about what can the product do for me. In my case, my curiosity is satiated, I'm happy, right? But in a lot of people's cases, it needs direct value to be added to their lives, and machine learning can help do that. But again, it really depends on the user experience, it depends on the design, it depends on the specific use case and the problem statement, right? So we'll get deeper into data in just a moment. But there is another thing, a question from Santosh asking, okay, this one's a bit more sort of open-ended and far into the future, but I do still want to ask, what is next after AI, after artificial intelligence?
I don't know. I think we are just at the beginning of machine learning and AI, so I think there's a lot more room for maturity of this technology. People talk a lot about biotech kind of being the next frontier. I certainly think that is an area that is incredibly interesting from a technology perspective, as well as quantum computing. Those are two that often get tossed out as sort of, the next frontiers. So I'll offer those as well, but
yeah, and I
have
also,
no idea.
I also feel like maybe what is next after AI isn't the best way to phrase it, because it's not like we're going to phase out AI and do something else.
Right. Yeah.
AI is still going to be one of those tools in our tool belt. Even if in the future we have infinitely more advanced technology, it's still going to be there, right? Just because quick sort and merge sort exist doesn't mean bubble sort's gone, like we've forgotten how it works, right? Again, not necessarily the best analogy, but
Yeah,
again,
I mean,
doesn't mean that it's
I
gone.
think of machine learning and AI technology a little bit more similar to like electricity, right? Or the internet, right? It is a game-changing, transformational new technology,
Mhm.
but also, it has upsides and downsides. It's not a panacea, and there's going to be more to come after it.
Absolutely. There's still going to be a lot more in the future, but it's still going to be here as a tool belt for us, as one of the tools in the tool belt, rather. Um, all right, now there are actually quite a few questions we're getting from the audience, so I do want to get one more. This one's from Peter. It's about your book, saying the title of your book is very impressive, particularly as the whole world is running after artificial intelligence. So how and why did you choose this title, and how have you decided to cover what your title alludes to?
Yeah, we looked at a lot of different titles. Naming a book is hard, I
Yeah.
figured out. Part of it is what we looked at what other books are already out there about machine learning and artificial intelligence, and we were trying to offer something new, to the community that didn't really exist before. We thought that the stories that we had to tell and the way that we compiled the sort of outline for this book was fundamentally different from, there's sort of two categories of stuff out there. There's a lot of like textbook type stuff, like learn how to practice and become an AI practitioner. And then there's a lot of like, oh my God, AI for idiots, or AI is sensational, and be scared of it, sort of business, pretty floofy books. And we wanted to do something very practical. So that's how we landed on a practical guide. We looked at a few other word choices, but and the other sort of emphasis that we wanted to put on was responsibility. Ethical implementations of machine learning are so important, and really they often are the key to deploying at scale successfully. Often a prototype or a sandbox project will sit on the shelf because of the ethical or responsibility implications. And so if you can sort of factor that in from the beginning, you will achieve success and be able to launch something to production at scale in the real world more successfully, when when you focus on responsibility up front. And we also wanted to kind of make AI less scary, less overwhelming. People are often pretty intimidated by the technology. I think I started this, I have a photography and American Studies liberal arts degree. I do not have a CS background at all. And I was able to get into the biz and learn the technology. And I just wrote a book, which is bananas and dyslexic. But I wanted to kind of break it down that it's approachable. It's something that it doesn't take a rocket scientist to do. We also need people who are not computer science backgrounds or only technologists in order to mature this technology, and grow it.
Absolutely. I mean, it's really about that sort of disconnect between, there's the sort of business end of artificial intelligence, there's, how it's actually applied in the real world for consumers. And I feel like a lot of different sort of resources online for learning about AI are really very much sensationalized, right? There's always this, this sort of
As
extra.
A or B,
Yeah.
or good or bad. And this is
Yeah.
really just like, no, like the behind the scenes is messy.
Exactly.
It's not that complicated. It comes down to a few basic principles and you can learn them. And by the way, don't make the same mistakes we did.
Exactly. That's exactly what it is, right? And I feel like within artificial intelligence in particular, there's always that extra sort of layer of complexity because of the biases that have been introduced by, like, for example, science fiction, right? Into what we expect AI to be versus what it actually is, right? Just because AI is called AI in the real world and also in science fiction doesn't mean it's the same thing. They're very, very different things. and
I think what is surprising to people who don't know much about machine learning technology is that it's really simple and like unsexy behind the scenes. A lot of times it's really a lot about data classification.
Yeah, exactly. I mean, even the most advanced tools really boil down to that, right? Like, people see GPT-2 generating text, and our brains just subconsciously go, wow, that's intelligent because it's generating text. Only humans can speak. It must be intelligent, right? It must be human. But then at the end of the day, it's literally just classifying, given all these words before in this sequence, what is the most likely next word? Which words category does this
Yeah,
belong to? And then it's just putting that in and then continuing with its probability
right.
distribution. That's all there is to it. And humans are way more complex than that. We don't just speak because we want to speak, right? We have thoughts that we then convert to language with the express intent of being able to get across that thought to other humans. That's incredible, right? So humans are way more advanced than AI.
In context, right, of
Yes,
what's appropriate, and that's the
precisely.
hard part.
Yeah, exactly. Context is another whole rabbit hole to get down into. But now, though, I do want to go ahead and answer. This is, I think, a really interesting question. This one's from Navin, asking on both LinkedIn and YouTube: is deploying AI models the same as just deploying traditional applications, for example, web applications? How hard is it to debug production errors for AI models? What are your thoughts?
So no, it's not the same. There's a different infrastructure that you will need for machine learning technology than a standard web app. One of the biggest things that I think is frequently overlooked is a monitoring system for transparency into the decisions that the machine learning system is making.
Mm-hmm.
And I'll actually reference YouTube. They do a really great job. That if you Google YouTube transparency dashboard, it'll come up. And what it shows is the percent of videos that are taken down programmatically from YouTube that don't meet its sort of content policy, right? So if there's something explicit or violent or whatever else, it will be taken down. And so YouTube does a really good job at this. Also, they're not perfect, right? And things get up on YouTube that are inappropriate and violate their policies. And so they are constantly monitoring for, with humans, right, what to take down in the cases where their machine learning approach does not catch it, right, and misclassifies it. And so even though the vast majority at this point, because they have such a mature technology in production, is taken down by their algorithms, a serious percentage are not, right? And you can look into it and you can see exactly, every quarter they show you how many videos are taken down by humans or because of legal issues, or they even have a category for governments. That's something that people often overlook, which is this decision that my algorithm is making programmatically to remove content or make a decision or whatever else, how good is it, and how much does it also need to mature, and what is it not catching? And that's something so critical for real world machine learning based applications, and YouTube's a great example. They do a really good job of it.
Absolutely. I mean, that's very interesting because I never knew that YouTube did those sort of transparency reports. So I'm going to look into that. YouTube traditionally, with a lot of the sort of machine learning that they do, I feel like they haven't necessarily have had the best rep in terms of transparency, especially with, I think, with creators, with their whole like new recommendation algorithm and things like that. But that's very interesting. So I'll definitely take a look into that, and hopefully that was helpful, Navin. And I also, just really quickly, as a developer, one of my major sort of pet peeves with AI, something that I think is something that we need to work on at the very least, is there's sort of two parts to AI. There's the science of machine learning. And I'm going to talk about machine learning specifically, not AI here. So there's sort of two parts to machine learning. There's the science of it, and then there's the engineering of it. And I feel like there's a gap between the world of, the sort of engineering and the science, in the sense of, if you were to implement a machine learning model that works on paper, that doesn't necessarily mean that your implementation is actually going to work. If you made a small mistake in the implementation of the science that you wrote, there's practically no way to just debug that. If you've got hundreds of different mathematical operations in your pipeline, right? And somewhere within the TensorFlow CUDA code base, there's an error in the CUDA kernel for the backprop of that specific operation. You're going to spend a lot of time debugging to try and figure out what that error is, because you're not just going to get an error, it's going to be the wrong model.
Well, I'll also offer a mistake that I made when I first started at Watson. I write about this in the book, which is that we were days away from launching a new visual recognition system,
Hmm.
and we were all excited, and we had spent all this time on accuracy, and someone had taken the time to explain to the idiot who was me what an F1 score is and how that worked. And we were like super focused on accuracy. And we were about to launch, and then someone, one of the researchers on the team, flagged it to me. He said, "Alyssa, we can't launch this." And I was like, "What are you talking about? There's zillions of dollars worth of investment. This is a very high profile thing. Like, we're launching it." And he was like, "No, we're not." And I was like, "What?" And he gave me a picture and he put it into the API, and the tag that came back was loser. And the picture was of someone in a wheelchair. And now that was horrifying for me. And I was like, "Oh my God, you're right. You can't launch this." Because it really sort of violated our sort of ethical guidelines and what the company stood for, and it wasn't okay. And so we didn't launch it. We fixed it, but that was, you can call it a bug. It's not really a bug, but it was a problem with the data that we had trained the system on, which is that we had given it training data that was not cool, and it was not reflective of our values, and we had mistrained the system. And so you could think of it as a wrong tag, right, or a bug, but really it was sort of a fundamental problem with a comprehensive understanding of the hundreds of millions of images that had gone into training this, and thousands and thousands of tags, and how could we really understand what was in there to know that we were training. And so debugging machine learning is often like that. It often comes back to issues with the data.
Yeah, it's there's just so much more to debugging machine learning, because when you're debugging normal code, it's very much something that humans at least can attempt to understand. Right, one of the things that lots of people have talked about, like programmers, like really popular developers have talked about, like leaders in the industry, people like Joel Spolsky have talked about, is programmers are not good at managing state, because state is complex, right? Like there have been Firefox updates in the past, for example, that have sometimes entirely erased user preferences, and there have been sometimes updates to like Steam, where the only option to actually fix the update and to get the application to launch is to delete all of your information, to reset, start from scratch. And that is simply because there's so much that goes behind an application's state, the environment that you've set up for it, that it's very difficult for programmers to keep every single combination of all those variables into account to know what to do next in a certain application. Modularizing these things can definitely help, but it's still very difficult. That's why, for example, Firefox has this thing where every like year or so they'll remind you, hey, it's been a long time using the browser. Do you want to reset all your preferences? And a lot of times when you do that, you'll have a faster browser, something that just feels more fresh, because now you've reset, you've lost that garbage state, and you're starting once again from scratch. And so within regular programming, even though it is difficult to keep these sorts of things in mind, it's possible to step in through a debugger to try and figure out what's happening where it shouldn't be happening and what to do instead. With machine learning, you then have lots of different issues, two of them being, for example, as you mentioned, you could have the wrong data, then you have to determine, what do we do with that data? How do we filter it? Does it actually make sense? There's just so much stuff to deal with there. But then also, did I make a mistake in the code that isn't really an error, but is now giving my model the incorrect math to learn from? And
In my experience in like real world AI, most of the problems fall into the data category, and very few of them, I mean, in sophisticated applications, right? Like that's kind of par for the course. There's always software bugs. There will continue to be that. But I think what's different to the viewer's question is really in the data.
Makes sense. Yeah, no, absolutely, right? Machine learning, there's all these different failure points, but again, within the real world, right, going back to what you mentioned, a lot of the applications are simpler than a lot of people expect. They're a lot dumber than people expect. And so, yeah, a lot of those sort of issues will fall into that category of, how do we deal with data? Speaking of which, I do want to go ahead and ask you that question that I was wondering about a little while ago before we get to some more audience questions. How do you define good data in the first place? That sounds very open-ended, right? That's a very much, I think, task-specific answer. But overall, how would you say someone can define good data for their use case?
Yeah, there's a lot in there, and I won't try to summarize 50 pages, but giving some high level qualities of good data. And this is not sort of comprehensive, but good data is relevant to the problem that you're trying to solve. It's recent, so it's not dated by months or years. Sometimes you want to have a long period to look back on, but frequently you don't want outdated information because it will not be good at solving your future problem. It's good to have transparency into the provenance of that data. And what that means is you want to be able to track the raw generation of the data all the way through storage and saving and any cleaning or manipulation that happens so that you know what transformations occurred. And often developers or machine learning data science folks are given a spreadsheet or access to some database, and they actually are making a lot of assumptions about that data when they don't know the raw source of it. And frequently things like empty states were turned into zeros, or there could be some sort of transformation that happened that fundamentally introduces changes to how the inferences that you can make with that data. Ideally it's data that is sourced from a diversity of perspectives if you're asking it to make a decision. So I'll give you one example. If you're asking I'll stick with the support ticket classification that we were doing earlier. If you're asking it to classify intent of how urgent is this? And what you don't want is the only one customer support representative giving you all the answers. You want 100 or 1,000 customer support representatives answering the same urgency question, because then you can have a diversity of perspectives of how urgent is this same question. So often you want multiple perspectives on the same decision. I could go on and on about data, but you want to know where it's from, you want it to be clean, you want it to be recent, and you want it to, knowing where it's from is also sort of like ethically sourced, right? You don't want to accidentally have data from a place that you shouldn't have data from, right? Whether or not someone didn't know they were giving it to you or is violating privacy concerns or HIPAA concerns or others.
Right, and I'm sure my friend Andy Martin would have a lot to say around specifically this point and how it ties into blockchain, and so hopefully we'll get to hear from him again soon on that. But in particular, one thing that I love from what you said is that you always want to get a diversity of opinions, because there's that one really famous game of guess the amount of like jelly beans in this jar, and if you get it close enough or if you get it right, then you win a certain prize, and barely anybody will actually get it right. But turns out that if you ask like 1,000 people to just give a random guess, right? Not necessarily a guess, but an estimate, like of how many jelly beans they think there are in the jar. Usually, if you average down those 1,000 estimates, you actually get a really close answer, right? And so humans individually might not be the smartest or perfect at a lot of these decisions. But when you take lots of our opinions and average them down, then the people who are really far off in either direction, really close, sort of average together to make the correct answer, right? That's what's incredible, right? Like this one time I was training an electrocardiogram-based identification system, and the data sets, they don't just have a single heart specialist going in there and looking at the ECG data and being like, all right, here's arrhythmia,
You need multiple.
Yeah, you want like 6, 7, you want tens of them, all looking at them and sort of averaging out these decisions. And if there's a dispute, being able to figure out, okay, why is there a dispute, right? Why do they not agree? What is the actual sort of classification here? So that's definitely very important.
Because I think there's gray. That's the reality of all machine learning based stuff, is you are trying to make structure in black and white out of an inherently gray situation.
Absolutely.
And so you need to deal with the gray, right? And you need to understand the gray and be able to live in that gray.
Absolutely, right? Being able to understand that you're trying to take something that's fundamentally unstructured and give it structure. And in doing so, you're going to lose some information. So you've got to make sure that you're taking whatever you do have access to and encoding it the right way. Right, so another question from the audience. This one's from Subramanian asking, do machine learning models go through the same general software testing lifecycle to identify bugs that might occur? This ties right back into your sort of point around like again, feeding an image into the Watson visual recognition system and getting like a wrong tag for something that's biased. I remember one time Google Photos and something they'd already deployed. Someone took a photo of their friends and it classified them as gorilla. And no, that's not how you want the visual
Classic
recognition.
example.
Yeah, classic
Yes.
example. But yeah, what do you think? How do machine learning models go through testing, and do they use the same general software testing lifecycle that we already use?
Yeah. So I would say good teams who deploy machine learning do put their machine learning models through testing. They're different from, I would say, the classic software QA, because what you need is data sets in order to test with. And what is ideal is a gold standard data set that is different from your test data around what good means, and often multiple different data sets that test for different things. So for example, if you're testing for gender bias, or if you are testing for outcome bias X, right? Those are the things that you want to test for that are different test cases than a traditional software stack. It's not it works or it doesn't, right? It's not yes, this is expected behavior or not. You are asking the system to reason, and that is so you need to ask it different types of reasoning decisions that you have reasonable answers for, and sometimes you will have a range of reasonable answers, and there might not be one correct reasonable answer, but those are the types of QA tests that you need to set up that are different from machine learning than your basic software application.
Right. I mean, it's difficult to test machine learning, to say the least, and it's important to make
but
sure.
It's so important.
Yes.
And if you don't test, you end up doing accidentally the sort of Google gorilla example that you just gave, which is it's not okay to not test it.
And sometimes no, go ahead.
I was saying, I think a lot of teams are still deploying machine learning without rigorously testing the reasonability of these systems.
Yeah, and a lot of the times these issues are so nuanced that it can be difficult to. It is fundamentally difficult to test, right? Like for example, Google has their new Smart Compose where you can, right, like type an email and it'll automatically fill out things, and based off of even if you were to like specify a certain, like for example, vice president is female, sometimes it would actually go ahead and sort of fill out things assuming it was male, right? So
right.
You have these sorts of biases that are just inherently difficult to find. But at the same time, it's not like the programmers genuinely had any kind of bias and they were like, you know what, we want to make it so it automatically assumes it's male. It's just in the data, so you have to find a way, as engineers and scientists, to be able to test these things, find these issues, and then introduce code to help mitigate this.
I feel really strongly about this issue. I think that it is incumbent upon anyone who's participating in that team. You can't say, oh, the data's biased, so therefore, so like, no, that's your responsibility to fix, and it's your responsibility to mitigate. And I think sometimes you can fix the data itself. That sometimes is possible. Sometimes you can set up a monitoring system in production to actively test for gender bias, right? Or sometimes you can do a design approach, which is our data's biased. That's just, we can't fix the data for whatever reason because it's ingrained in the language. But we could come up with a design approach sort of as a veneer on the output to say whenever we're using pronouns that are gendered, right, we give an option of another pronoun, which is an approach that Google took with Google Translate that I talk about a little bit in the book around Turkish language translation for a doctor versus a nurse, and they couldn't fix the underlying data, but they chose to take a design approach that was, I think, pretty successful.
And I feel like that also opens up the door to a lot of other really interesting applications where then you start to use artificial intelligence to monitor artificial intelligence, which is sort of like another area in and of itself, and also introduces a lot of its own issues of bias, but at the same time does have some kind of promising results. Like I've seen, for example, instances where, as you mentioned, being able to detect these sort of ungendered pronouns in one language being translated to gendered in another language, and being able to then be like, all right, using another machine learning system that's supervising this one in the translated output, we can say, all right, we use these pronouns here from a generally ungendered sort of pronouns from the original language, can we go ahead, like as you mentioned, show the user options? Hey, do you want to be using he or she or it or whatever it is? And so, giving people options, this can also be powered by AI. So there's a lot of ways that we introduce problems with AI, but then we can also work towards solving them with AI, right? There's a lot of really fun things we can do that I think are important to sort of explore. And one more question from C. Subramaniam asking, what blogs or other resources do you follow to keep up to date with the latest in AI technology?
I follow a lot of things. I actually have Google Alerts set up for myself on a bunch of sort of key industry keywords such as machine learning or AI, and I sort of scan the headlines every day and look at some of the key things. There are more people that I follow rather than particular blogs, and people who have mentored me or I look up to, and those are the ways I keep up to date.
Absolutely, great to hear. Yeah, I mean, it can kind of be hard to answer questions like that. I mean, I sort of get that a lot, and it's not like a very specific resource that I use or try or really use to sort of keep up to date. It's really more generally taking a look at all kinds of different things, whether it's reading new papers that I find interesting, or following different people that are doing great work in the world of AI, reading books like, for example, your book, Realworld AI, that I can't wait to dig into. So. It's all
You
kinds
also
of
have to just do. You can read all you want online,
yeah,
but you learn a lot by doing, right? So
absolutely,
I recommend doing.
absolutely. Learning by example and actually implementing things, you can never really beat that real experience, right? All right, so now with machine learning technology, we've talked a lot about machine learning technology and actually applying it, and using data and what good data means in the first place and all these different things. One thing that I've sort of tried to use as an analogy before within the world of machine learning is when you're training an AI system, a lot you sort of compare it to, for example, training a puppy, right? You're trying to give it different examples and sort of reinforce, hey, with this input, this sensory input, this example is, or this behavior is desirable, but this sensory input, this certain behavior is undesirable, right? And you're trying to create that mapping from X to Y, except with puppy, it's natural intelligence, so it's a bit, I guess, in a way, oddly easier, because then you have organic
I have a
intelligence.
well-trained puppy. Well, at least
Oh,
she
yeah?
used to be.
Nice. And I feel like with machine learning, it becomes harder, right? Because then you don't have that organic intelligence that can be motivated by treats. You now have math that needs to be motivated by human written objective functions, which are really difficult to write, at least to write them the right way.
I think one of the big challenges, taking your puppy example, is really around thinking of all the things ahead of time and situations that this might be applied to that you can't think about ahead of time, right? The puppy sit, stay, down, those are very transactional and simple. With machine learning, you're putting it out, you're asking it to understand context and make decisions around inputs that you don't know what the input is going to be in the future. So if you can constrain the inputs, and so take Siri or a Google Home or something, right? If you're constraining it to someone's kitchen and you're only selling it to people who speak English, and you're only selling it to adults, and you're selling it to people who live in a certain income bracket in a particular country or a particular place, you have relatively more control. But what if someone's visiting in that kitchen from another state and speaks a different language, right? That you can't control the inputs. And so that's kind of what's different about machine learning. You never know what people are going to use it for.
Absolutely. I mean, as we mentioned, people will find ways to demolish software in ways that are really very much unpredictable.
Yeah, I mean, the Italian grandma of OK Google video, I'm sure you've seen. That's my favorite one, right?
I haven't seen that yet.
I'll send it to you. It's this great video. Someone gifts their Italian grandma a Hello Google device, or I don't know what it's called, for a Christmas present. And the grandma can't say the word Google. Like her pronunciation of it's difficult. And the system keeps not like figuring out what she's saying, even though the grandma is saying, okay, Google, hello, Google. It can't interpret the wake word, sort of wasn't trained well to understand the Italian grandma.
Interesting.
And it's a hysterical video. I'll send it over.
Yeah, I definitely want to take a look at that. I'll link to that in the description as well. But again, sort of goes back to you want that diversity in data, right? If we want Google to be able to train these systems to not only be good at identifying words spoken by people with a very specific accent, but really as many people around the world as we can, right? So that also opens up this whole other issue of, again, how do you get that diversity of data from all these places across the world?
Yeah.
And again, like one of the things that I like to bring up, one of the examples I like to bring up, is this one blog from or this one article that my mentor Timothy Duncan wrote about the sort of state of policing in the US, and talking about how the reason we're in such a bad state today is because of the fact that, or at least partly because, the grant office sort of incentivizes police departments based off of the number of arrests they can make. So they're really only incentivized to do as many arrests as possible, not necessarily high quality arrests in the sense of, only when it's necessary, or to help people actually get back into the real world and contributing to society. That's not an incentive, right? And so what I feel like a lot of people need to realize is that whether it's natural intelligence or artificial intelligence, whatever, you always have a certain goal. You have a certain incentive that wants to be reached.
Incentives are
And
so key.
oh yeah, and a lot of the times you'll have a certain intention of, okay, this is the path and this is the incentive at the end of the path. But people will find a completely different path to get that incentive if that other path is shorter. When you have that incentive in place, people will find the absolute simplest and easiest way to get to that incentive possible, right? And so that applies to both natural and artificial intelligence. If you're training
Like
your system with the wrong
managing a
objective,
team, any type of team that you're managing, the outcomes are so key. One of the things I like about Blue Shield is from a bonus structure internally for managers. Everyone's bonused on, some business metrics and outcomes, but everyone's also incentivized around how they achieve them, right? And achieving those outcomes in the right way. And there's a lot of emphasis on that because doing it by bullying or by any means possible or whatever, that's not the right way to run a business. And I couldn't agree with you more.
that's very nice. Yeah, it's all about being able to design an objective the right way, whether it's in the real world with teams or with artificial intelligence, being able to not only feed the right data, but train the system with the right objective upon that data to achieve the use case that you want. Right, like going back to the fall detection example, it just so happens that the objective in this case is, given some accelerometer and gyroscope data, predict 0 or 1, did the user take a fall or not. And that objective was great. It let the machine learning model learn exactly the kind of mapping that was necessary in order to enable this kind of user experience. But in a lot of cases, you might get the wrong objectives. OpenAI, for example, this is one of my, I guess you could say, favorite examples, is for example, training neural networks to predict the next word in a sequence to then create neural networks that can write content.
Mm-hmm.
But that's not how humans write. That you don't just look at a sentence and think, what would the next word be globally without any sort of particular thought behind it, just generally what's the next word that would generally accompany all these other words, right? That's not exactly the way we should be training systems to write, because they're not writing, they're just a language model.
Generating content.
Yeah, exactly. Generating raw content.
Well, that's the difference between writing and generating content, right?
Exactly.
You just nailed it.
Exactly. And so that's something we need to keep in mind. It's objectives. At the end of the day, whether it's AI or natural intelligence, it's all about objectives and that North Star metric. All right, there is one last question I want to take up today. This one is once again from C. Subramaniam, asking for a newbie, what is within the stream of AI good to find a job opportunity? So where are the job opportunities within AI?
Well, it depends what you call AI. There are lots and lots of job opportunities annotating data. Right now, you can, start annotating data, and companies will pay you to do that. If you're looking to be more of a sort of practitioner or build models, that's a different angle to it. If you're looking to design these types of interfaces, these systems, it's a different angle to it. I always give the advice to people, which is just start, and get some experience under your belt, even if that's a student project or something online, like a contest or a sweepstake, there's a lot of value in starting. And there's a lot of there's a big skill gap in the industry. The industry is desperate for people with machine learning based skills. And so it's actually a fairly easy industry to get into. I myself have zero of the right credentials and was, lucky enough to be given an opportunity as a product manager. So take the skills you do have, right? I had product management skills and I applied them towards this technology because I was fascinated by it. And I thought, oh, this has some really cool options for it. And so I learned, but be humble, right? I took a lateral, almost a sort of down step in my career in order to look and be around this technology. And that's okay. That was fine with me. I was, mentors of mine were giving me advice of no, stay the course, go on this path. And I was like, I'm going to do a hard left turn. I've done that a number of times. And personally, it's always worked out for me. But I think, do work that excites you and there will be job opportunities.
Absolutely. Goes right back to something that I love to say, and that is do what you're passionate about, right? Like regardless of what it is, could be code, in my case, that's my passion is writing code, developing technology. That's what I love to do, right? And that's why I've been able to do the things that I do within tech is because I'm just so passionate about it. I just end up spending, a lot of my time coding because I just love doing it. Right? And so it's never work, right? So same thing with you, figuring out what it is you're passionate about, even if it takes a lot of that experimentation to figure it out. Once you do, take risks and follow what it is that you want to do. That I think is really important, because then you'll be good at it. Then you'll persevere.
You might not be good at it at first, but at least you'll be happy doing it.
Exactly. Yeah, I feel like a lot of people kind of forget that, is that everybody that's a professional in any field today was at one point had absolutely no knowledge about that field whatsoever, right? Everybody has to start from scratch. It's just that if you're passionate about it, you're going to learn quickly compared to someone who's not passionate.
Well, you'll like learning, right? Or you'll have fun doing it. And jobs and careers, they're far more circuitous for most people than it looks like on their LinkedIn resumes. So, it looks so logical. You did this, then you did this, then you did, but no, that's not how it works in the real world. It's messy and it's all over the place. And I think kind of pulling that back the veneer and trying to, be humble and understand, what do you like to do and what's exciting and just try to do more of that. I found the opportunities come my way.
Right. Wonderful. Thank you very much for sharing, Alyssa. This has been really, really interesting. I've been very happy to be able to answer a lot of the questions that the audience had for us today, and thank you for sharing your thoughts. But one more thing I do want to ask you before we end today's episode is, you've gotten sort of like a good sense for our audience today based off of the questions, and, it's been great to hear your insights. But before we leave, is there sort of like a closing message that you just want to share with everybody as to, what you want to leave them with?
I would leave them with, don't be afraid to try and get started. But when you are using machine learning based technologies, be humble about the potential damage that you could inflict unintentionally, and try really hard from the beginning to ensure that you are using this technology responsibly, because it can have some outsized really positive or outsized negative impacts. And so harnessing it and being really mindful and being good stewards of it are critical to putting it to work for good for the next generation.
Being humble is absolutely the key, right? There's so much technology that we develop that can do a lot of good, of course, but at the same time can be harmful, right? In a lot of ways maybe people don't expect.
Yeah.
And so being able to...
It's what you don't expect that gets you. Gotcha, every time.
Exactly. You have to expect the unexpected is what we're saying here, right? Be able to look into something. And that's exactly why diversity is so important as well, right? Being able to have a wide variety of opinions at even just the development table, and being able to say, this is what, X person thinks, but, Y person thinks completely differently, and is seeing this other angle. That's really important. And so Thank you very much for sharing. It's great to hear all of your thoughts on the world of artificial intelligence. You've given me a new perspective on a lot of different issues and a lot of different topics, all the way from thinking about what the difference is between AI and machine learning, and what sort of enables an application to take that jump from machine learning to AI in people's eyes, all the way to understanding what data is, or what good data is rather, and how we can work towards ensuring the ethical application of it.
It's a privilege to be here. Thank you for having me.
Of course, thank you for being here. And of course, thank you everyone for joining me today. And of course, make sure you join us next week on Sunday. We have some really interesting stuff coming up. Stay tuned to hear more about that. And of course, once again, thank you everybody, and goodbye.